All right, this next section is gonna go into special right triangles. Starts with just regular right triangles, then relationships with right triangles, similar right triangles, and then special rights and tricks. So, Pythagorean theorem, like if ever you've been given two sides of the triangle, remember C is always your hypotenuse, and your C is always opposite the right angle. So this would just be 6 squared plus the x squared equals C squared. Oops, sorry. Equals, oops, why do I keep doing that? Sorry about that. Equals 22 squared. 36 plus our x squared. Oh, I gotta fix this pen. What is like 22 squared? It's like 484, yeah. Alright, so now we're just solving for x, but we have to isolate the x squared, which requires minus the 36. So I'm just going to write it over here. This is going to give me x squared equals 448. And then we want to take the square roots of that. Let's change this to get the x, to solve for x, excuse me. Here, taking the square root of 448. And this is not a perfect square, so we need to simplify it into, let's see, a large perfect square that goes into it would probably be 16. Is there one larger than 16? Yeah. 64. Yeah. So remember when we did this, when we simplified, 64 is a perfect square, so we square that. That's gone. It comes out as an 8, so this would be 8 root 7. Okay. Now I kind of wanted to address number 22 as well, because just remember on your setup what happens when you square a radical. So like this would be 1 squared plus x squared equals, you need to put this in parentheses, the square root of 37 squared. And whenever you square the radical, basically it gets rid of the radical. So this is 1 plus x squared equals 37. We're solving for x, so we need to, oops, sorry. Solving for x, so we need to get the x squared by itself. So our x squared equals 36, and then we're taking the square root of that. So our x is 6. Okay. Now, understanding simplifying radicals, doing your Pythagorean theorem will help you when you have geometric mean. This is when you have similar triangles. And there was 2 rules when we did this. I think it was a yellow paper. The altitude rule. The altitude is the segment that goes from the right angle to the hypotenuse, and put a little lowercase a there. And the altitude separates the hypotenuse into 2 parts. And put a P and a P. So when we did the altitude rule, it was basically P is the acronym we could use. It was the heartbeat rule. Okay. So if I'm just labeling the sides that correspond, it goes part. This first part is the CT to the altitude, which is AT, back down the altitude, which is AT again, to the smaller part, which is TS. Okay, so we're just kind of recapping the setup here. Now, the other rule with similar right triangles with geometric mean is dealing with the hypotenuse and the adjacent part. So this whole segment here would be our hypotenuse, and if I'm not trying to identify the altitude, the inside, this hypotenuse would go to the excuse me, the leg, and we then want the adjacent part to that leg, which is here. Okay, and we did this as whenever we have the hypotenuse, we call this our boomerang method. Okay, so we can do it to the small leg here, which is AS, so that means we're doing the whole hypotenuse. So it was hypotenuse, leg, leg part. Okay, so the whole hypotenuse is CS. It goes to AS, which is the leg, back down the leg, AS, to the adjacent part, which was TS. Now, I can do that same boomerang going to the left leg. I could use this leg over here. So that would still be the hypotenuse CS to CA, as CA is now its adjacent part would be CT. So just kind of recapping the setup. And that's what you're using to solve for your variable here. So like if I'm solving for y is the altitude. I need my two parts that the altitude splits the hypotenuse in, and we're using our heartbeat method, which is part over altitude equals altitude over part. So if I substitute that in, I could start with the 5 part or the 4, doesn't matter. Go to the altitude, which is y, which equals y over the other part. So when I cross multiply, our y squared equals 20, and then we have to take the square root. This is not a perfect square, but 4 times 5, 4 is a perfect square. So my y, because I'll take that out, would be 2 root 5. Okay. Now to do your x, you're doing the boomerang. Okay, so you have to do the whole hypotenuse here. That means adding these parts together. Let me just fix this real quick. So the 5 and the 4 means my hypotenuse is 9. 9 over x equals x over 4. So x squared equals 36. And 36 is a perfect square. So x equals 6. Okay. So on number 26 here, I don't know why it's not letting me. Sorry, why it's not extending. But you're going to have to first find y using Pythagorean theorem, and the y is here, right here, using this right triangle. So either Pythagorean theorem or recognizes a triple. Then once you get that number, then you can go to find your z using your heartbeat with the altitude here on the inside, and then you have to use boomerang. Okay. Now, I'm not sure why it keeps showing the extension. I wonder if I do. Nope, that doesn't fix it. It was supposed to extend so you can see the bottom here, but it's not doing that. So apologize for that. So now we get into some more right triangle problems that are shown. Okay, I was just making sure. Sorry about that. All right, here the keyword is equilateral, which lets you know that all the sides are congruent. It's equilateral. And if the perimeter is 30, that means each side is 10. Okay. They want the length of the altitude. That's the height, basically. It's the same thing. It's the distance from the vertexes. And the altitude bisects the side. So what it creates is a 30, 60, 90 triangle here. If it's equilateral, each angle is 60. But then the altitude bisects, so this angle up here is the 30. And to find the altitude, which is here, this represents the long leg, and the 5 is my short leg. So my altitude would just be 5 root 3. Alright, so you do need to remember your rules for 30, 60, 90 versus 45, 45, 90. Some students prefer using the table. So like for a 30, 60, 90, this was our short leg, our long leg, our hypotenuse. Okay. This would be X. The short leg and the hypotenuse have a relationship. Short leg is half the hypotenuse or double, and you get the hypotenuse, and this is X root 3. So if I'm plugging in based on what I'm given here, I'm given the short leg, which is my 8 here. Remember, if I go small to big, anytime I'm going to a bigger side, I'm multiplying. So if I double my 8 here, my X here is just 16. My Y would just be 8 root 3. Okay. Now for 45, 45, 90, this is when we have to remember the two legs are congruent because we have two congruent angles with the 45. So these two are the same, X and X. And this has X root 2. And this should have been 12 here, that's what's missing. Here we're going from big to small. Anytime we go big to small, we divide. So that means I'm going from here to here, which means I'm dividing the 12 by root 2. And I cannot leave a radical on the bottom. We have to rationalize that, which means this becomes out to be 2 root 2 over 2. Because we want to get rid of the radical at the bottom, and this can be simplified. So 2 can go into 12 6 times, so 6 root 2 is our answer. Okay, so we're asking to remember when you go big to small, like on 30 here, this is the hypotenuse. You want to always, this is my long leg, this is my short leg. And at 30, 60, 90, you always want to go to the short leg first. And that will, hypotenuse to short leg means you're going to divide by 2. So hopefully we recognize this is 5 root 2. And then to get the long leg, you're taking the short leg, you're taking your short leg and multiplying by radical 3. Our short leg is the 5 root 2. So I'm now multiplying by radical 3. That would be 5 root 6. So sometimes you are going to still have radical answers here. Okay. And then when we get to 33, now we're getting into trig. Okay. Well, on this one, 34, you can still use 30, 60, 90. But any angles other than 30, 60, 90, or 45, this is when we start off, we circle the angle. 18 is my opposite. X is my hypotenuse. This is when we have to remember our acronyms. So Katoa sine is opposite over hypotenuse. So Katoa, the Ka is adjacent over hypotenuse, and To is O over adjacent. So I have a O, an H that is sine. So you have to remember how to write this out. It's sine of the angle, which is 40 degrees, equals 18 over X. And then we have to remember what we do when X is on the bottom. When it's on the bottom, we switch it, we do division. So X is going to be, I'm basically moving this to where X is. And so this would be 18 divided by the sine of 40. So you're going to have to put this in your calculator. And remember, I have my calculator on this one. Remember to make sure your calculator is in degree mode. So we're doing 18 divided by the sine of 40. This comes out to be approximately, oh, well, 28.0. You can't really round it up here because there's 2 more zeros. Okay, so we get to 35 and on, this is our trig. Okay, so our steps is always circle our angle or what part we have inside the triangle, then label the sides accordingly. So this x is adjacent to the angle, and this 12 would be opposite. O and A would be tangent. So this would be tangent of 14 equals 12 over x. Again, the variable's on the bottom. Now on 36 here, we got x is our angle. We have our opposite hypotenuse. But because x is our angle, sine of x, and we're trying to find the angle, this is when you have to remember to find the x, you're doing sine inverse, which is at -1, and then dividing 19 over 20. Okay. So when you get to 40 and on, now we're doing some word problems, and a couple things you gotta remember. Because we're using trig, you can only use that with a right triangle. So our doesn't have to be the scale, but every time we're gonna have to draw a right triangle to associate our word problem. And in this scenario, since a wire is attached to the top of the pole, or your pole would have to be this vertical distance here. Okay. And it is 30 feet from the foot of the pole, so 30 feet from the foot of the pole would be here. The angle of elevation, okay, doesn't matter if it's elevation or depression, it has to be made with the horizontal line. And so the 58 will go here, so let's find the length of the wire, that's our hypotenuse. So what we have here, the 58 is our angle, that's a 58, doesn't look like that. 30 is the adjacent, x is the hypotenuse. So this would be cosine of 58 equals our adjacent over hypotenuse. Again, x is on the variable on the bottom, so we have to remember to switch and divide on a situation like that. So remember what I was saying earlier, it doesn't matter if it's elevation or depression, the angle has to be made with the horizontal line. That's the line right here. So I know this is the angle depression to the top of the lighthouse. Okay. It's to the top of 120-foot lighthouse. That would be here. To the ship is 44 degrees. So that's here. And then how far? That would be our horizontal distance. Because the ship is like in the wall, in the water somewhere. Okay. So just make sure we're using horizontal lines to label our angles. Okay. Unless it specifically says with the vertical. You got some more word problems here. Once you draw it, you want to be able to come up with the trig ratio, the trig equation. Sorry, this is going to be 70. How high? Okay, so opposite, adjacent, the tangent is 70 equals x over 10. So the scenario here, when the variable's on top, we cross multiply. This is going to be 10 times the tangent of 70. Make sure you keep the tangent and the angle together. You don't multiply the angle to the number. And then another scenario, and then we get into area. Okay, so pause this. So that's going to be a different video.